Hey guys, what are you doing?
We are booking flight ticket to China.
Wow.
Have a seat. Thank you. That's great.
Thank you.
Hey, do you guys know anything about China?
Yeah, I know, guys. You guys know, right? China is good in technology.
Yeah.
So,
China is a populous nation in East Asia with a total population of 1.414 billion. China has undergone a continuous and spectacular economic growth since the beginning of 1980s. China's economy is measured by its gross domestic product. In 2017, growth was 23.1 trillion, which was the largest in the world. That's 6.8% more than in 2016. As an additional information, only 3.3% of the population lives below the poverty line. China has 20% of the world's population. As its people get richer, they will become bigger consumers. More companies will try to sell this market because it is the largest in the world. They will tailor their products to Chinese tastes. China is now the world's biggest producer of aluminium and steel, and its exports rose 25% in 2015.
There's much information about China. No wonder they're good in economy. So how it can be related with economic theory? You guys still remember that we learned about this Solow model in Dr. Rosmawati class?
Yeah.
Good. So you guys still remember the equation also? Y equal to Z function of capital and labor?
Yeah.
We are going to be using a super simple version of the Solow model down to just a key variables and some basic mathematics. Although it's simple, the Solow model can provide us with some deep insight into the causes of growth. A key part of the model is a production function, a simplified description of how resources inputs are used to produce output. So let's take a look of some of the inputs in our production function. First, key input. We have physical capital represented by K, human capital represented by E times L, and ideas represented by A. We are going to hold human capital and ideas constant. That will let us focus in our case so we can show what happened to output when the amount of physical capital change. Since capital is the only input, output is function just of the quantity of capital. Let's write output with the letter Y. Then we can say that Y is a function of K, or output is the function of the quantity of capital. What properties should our production function above? First, it makes sense that more K increased output. For example, our farmer. A farmer with a tractor can produce a lot more output than a farmer with just a shovel. Similarly, a farmer with 2 tractors can produce more output than a farmer with just 1 tractor. So, in conclude, we can take human capital, physical capital, and ideas being used together to produce output. That's the idea of our production function.
I know. There is a graph that can explain the Solow model further. It is like this.
Investment is related to depreciation. We can explain investment and depreciation on the same graph. Depreciation is growing and the same as investment. This is when investment is greater than depreciation. That means capital stock is growing. But as when investment grows, depreciation will intersect with investment. And when this happens, we reach steady state level of capital. This is the key point to understand the Solow growth model. At this point, investment is equal to depreciation, meaning that all investment is being used to repair and replace existing capital. In other words, when we reach steady state level of capital, we also reach steady state level of output. here, depreciation is greater than investment. That means all capitals are being repaired but with not enough investment. So capital stock shrinks. Here, investment is greater than depreciation. And here, depreciation is greater than investment. At the end, efficient level is when we are at the steady state level.
So how are we going to relate the Solow growth model with the issue that I've mentioned earlier?
Oh, I know. Let me explain it.
This is the Solow diagram explained by Haida just now. So now, let me explain what is going to happen when total factor productivity increase. So this is the production function, where A denotes as total factor productivity. What will happen if the A is bigger? Then this line will shift up by some amount, but also keep in mind that the investment line is also function of total factor productivity. The investment line is going to shift up. Since the break-even investment line is staying constant and investment line is going to shift up, the capital per worker is going to have a new higher steady state level. To give you guys a clear picture on this, we are going to create a new line on the same graph to show you guys how the higher total factor productivity impact the Solow diagram. Okay, I'm going to use A subnode to indicate the initial total factor productivity, while A sub 1 as our new total factor productivity. As you guys can see, this is the initial output per person curve. Meanwhile, the Y prime is the new output per person curve. So we can prove that higher total factor productivity given any capital per person will result to a higher output per person. Similarly, with our investment line, we are going to have a new investment line. I prime denotes the new investment line.
So how you can conclude that? I can conclude overall China has shown a great example and the country can relate it with Solow growth model.
Exactly. Now I feel like I can't wait to fight in China.
Hey, you guys want to